If your computer programs look like a jumbled mess, you're probably not using Java. Let me show you why Java is so awesome. Java is one of the most popular programming languages in the world. It's like the Swiss Army knife of coding, versatile, reliable, and super user-friendly. First off, Java is everywhere. From your smartphone apps to big enterprise systems, Java is the backbone of countless applications. And guess what? It's been around since 1995 and still going strong. Write once, run anywhere. This means you write your code once and it can run on almost any device without any tweaking. Cool, right? Plus, Java is an object-oriented language. Think of it like building with Lego blocks. You create small, reusable parts and fit them together to build complex systems. Worried about starting? Don't be. Java has a huge community and tons of resources to help you out. Whether you're building a game, an app, or a website, Java has your back. So if you're looking to start coding or level up your programming skills, Java is a fantastic place to start. Happy coding, and may the Java be with you.
Ever wonder what JDK, JRE, and JVM are in Java? Let's break it down quickly. Think of Java like making a sandwich. Here's how it breaks down. Java Development Kit, or JDK, is your kitchen. It's got everything you need to make a sandwich: bread, fillings, and condiments. It's your complete toolkit for making Java applications, including the Java compiler and the Java Runtime Environment, or JRE. Java Runtime Environment, or JRE, is like your sandwich plate. It's where you put the sandwich to eat it. It includes the Java Virtual Machine, or JVM, and the core libraries needed to run your Java programs. It's ready to serve up your code, but doesn't have the ingredients to make it. Java Virtual Machine, or JVM, is the sandwich server. It takes your delicious sandwich or Java bytecode and makes sure it tastes great on any plate or device. It's the magic that makes your sandwich work everywhere, whether you're at home, at a picnic, or at a party. So to sum it up, JDK equals kitchen for making sandwiches. JRE equals plate for serving sandwiches. JVM equals server that makes sure your sandwich works everywhere. Enjoy your Java sandwich.
Hey Java learners, let's talk about how your Java code goes from text to a running program. First up, you write your Java code in a file with a Java extension. This is like writing a recipe. Next, you compile your code using the Java compiler, Java-C. The compiler checks your recipe for errors and converts it into bytecode, which is stored in a .class file. Think of bytecode as the ingredients list. Now, it's the Java virtual machine's turn. The JVM reads the bytecode and translates it into machine code that your computer understands. It's like the chef in your kitchen, cooking up the meal based on your recipe. Finally, your program runs. The JVM ensures it works on any device, making Java platform independent. It's like having a universal chef who can cook your meal anywhere. And that's how Java turns your code into a running program. Keep coding and see you in the next video. Follow and subscribe for more Java tips. Hey Java learners, let's dive into the basic syntax of Java. First, every Java program starts with a class definition. The class name must match the file name. So, Hello World is saved as helloworld.java. The main method is where the program starts. It looks like this. System.out.println prints text to the console. It's how we say Hello World in Java. Curly braces define the beginning and end of code blocks, like for classes and methods. Each statement ends with a semicolon, which is like a period at the end of a sentence. That's the basic syntax of Java. Keep coding and see you in the next video. Follow for more Java tips. Hey Java learners, let's talk about variables and data types in Java. Variables store data values. You need to declare a variable before using it. Here's how you declare different types of variables. Int stores integers. Double stores decimal numbers. Char stores single characters. Boolean stores true-false values. And string stores text. Each data type specifies the size and type of data that can be stored. For example, int is for whole numbers, while double is for numbers with decimals. Here's a quick summary. 1. Int is for integers. 2. Double is for decimal numbers. 3. Char if for single characters. 4. Boolean is for true, false. 5. String is for text. That's a quick look at Java variables and data types. Keep coding and see you in the next video. Yeah. Hey Java learners, let's dive into Java operators. Operators are special symbols that perform operations on variables and values. Here are some common types. Arithmetic operators perform basic math operations. Add, subtract, multiply, divide, and find the remainder. Relational operators compare values equal to, not equal to, greater than, and less than. Logical operators are used with Boolean values and, or, and not. Here's a quick summary. 1. Arithmetic operators are plus, minus, asterisk, / %. 2. Relational operators are double equals, not equals, greater than, less than. 3. Logical operators are double ampersand, double vertical bar, exclamation mark. That's a quick look at Java operators. Now, a quick quiz. What will be the value of int result in 10% for? Let us know in the comments. Keep coding and see you in the next video.
Exposing the secrets in Java control flow. This is going to blow your mind. Control flow statements determine the order in which statements are executed. Let's start with if-else. If-else statements execute code based on a condition. In our example, it checks if number is greater than 0. If true, it prints positive number, otherwise negative number. For loops run a block of code a set number of times. In our example, it prints the value of I from 0 to 4. While loops keep running as long as a condition is true. In our example, it prints the value of the count from 0 to 4 and increments it each time. Simple. Do-while loops? They always run the code block at least once before checking the condition. Do-while loops are similar to while loops, but they run the code block at least once before checking the condition. In our example, it prints the value of k from 0 to 4. Quiz time. What will this code print? Let us know your answer in the comments. Keep coding and see you in the next video.
Hey Java learners! Today let's talk about typecasting in Java. Ready? Let's go! In Java, typecasting is the process of converting one data type into another. There are two types, implicit and explicit. Implicit casting, also known as widening conversion, happens automatically when you assign a smaller type to a larger type. For example, converting an integer to a double. Here, the integer num is automatically converted to a double d-num. Easy, right? Explicit casting or narrowing conversion is when you manually convert a larger type to a smaller type. For example, converting a double to an integer. In this example, my double is explicitly cast to my int. But be careful, explicit casting can lose information. That's typecasting in Java. Quick quiz, what will be the value of int result equals int 7.99? Let us know in the comments. Stay tuned and subscribe for more Java tips.
Hey Java learners, today let's dive into arrays in Java. Ready? Let's go. An array is a collection of elements of the same type stored in a contiguous memory location. Arrays in Java are fixed in size and can store primitive data types or objects. First, let's declare an array. Here is how you can declare an array of integers with space for 5 elements. You can also initialize an array with values directly. Here is an array with 5 integers. Access elements using their index. Arrays are 0 indexed, so the first element is at index 0, gives us 90. You can modify array elements by assigning new values. Here we change the second element from 85 to 95. To get the length of the array, use array.length. In our example, scores.length, which will returns 5, since it has 5 elements. To iterate through an array, we use a for loop. This loop prints each score in the array. You can also use an enhanced for loop for a cleaner syntax. Quiz time. If we change scores 3 to scores 3 plus scores 4, what will be the new value of scores 3? Let us know in the comments. Follow for more Java tips. Want your Java programs to get a bit more chatty? Let's learn how with the scanner class. First up, why bother with user input? Imagine creating a program that asks for your name, age, or favorite number. Pretty cool, right? It makes your program dynamic and interactive. To get started, we need to import the scanner class from the Java util package. Think of it like inviting a friend over to help out. Next, create a scanner object to read input from the keyboard. It's like setting up a microphone to listen in. Let's try reading a name, age, and height. Imagine you're filling out a form. Easy peasy. Want to read an array of numbers? Think of it like jotting down your favorite numbers in a list. And remember, always close your scanner. It's like hanging up the call to save your phone battery. That's how you get user input in Java. Now it's your turn to try it. Don't forget to like, share, and subscribe for more Java tips. Hey Java learners, today we're diving into multidimensional arrays. Imagine a regular array as a row of lockers. Now a multidimensional array is like a school building with lockers on each floor. Each floor is a different row, and each locker is an element. Simple, right? Here's an example, a two-dimensional array like a table with rows and columns. To get the number 1, you look at the first row, first column, matrix index 0, 0. To get 6, it's the second row. Third column in the matrix index is 1, 2, as the index starts from 0. Multi-dimensional arrays are super useful for things like game boards or seating charts. Start simple with two-dimensional arrays. They're your first level in Java. Quiz time. What will matrix 0, 2 plus matrix 20 give you? Drop your answer in the comments. And don't forget to follow for more Java tips. Hey Java beginners! Today we're exploring strings, one of the most useful tools in Java programming. A string in Java is a sequence of characters. Think of it like a sentence or a word you want to store and manipulate in your code. Here's a simple string. It's just a piece of text between double quotes. Easy, right? You can also join strings together, like adding a name to your greeting. Java makes it super simple to concatenate or join. Strings using the plus operator. Want to grab a specific letter? You can do that too. Charat0 gives you the first character of the string. Strings are super useful for handling text in your programs, whether you're displaying messages, taking input, or processing text data. Quiz time. If string full name equals John Doe, what does full name.charat4 return? Drop your answer in the comments. Follow for more quick and easy Java tips. Happy coding!
Hey Java learners! Today, we're diving into some must-know string methods that will make your coding life easier. Strings in Java are more than just text. They come with powerful methods to manipulate and analyze text. First up, the length method. It tells you how many characters are in your string, including spaces. Next, to uppercase and to lowercase. These methods convert your string to all uppercase or lowercase letters. Want to check if two strings are the same? Use equals. It returns true if they match exactly. Need a specific part of your string? The substring method is your go-to. Just give it the starting index. And don't forget index of, which tells you the position of a character or substring. These methods are super handy for processing and analyzing text in your Java programs. Quiz time. If you use greeting.replace, 0, what will the output be? Let me know in the comments. Hey Java learners, today we're diving into string builder and string buffer. You might be wondering, what are these? Don't worry, I've got you covered. Remember how we talked about strings being immutable? Once you create a string, it can't be changed. This is great for some things, but what if you need to modify a string multiple times? That's where string builder and string buffer come in. Let's start with string builder. It's like having a whiteboard where you can easily change the text. Here's an example. We start with hello, and then add world without creating a new string. It's efficient and fast. Now let's talk about string buffer. It works like string builder but is thread safe. That means if you're working with multiple threads, string buffer ensures your data doesn't get messed up. However, this also makes it a bit slower than string builder. So when should you use these? If you're just working with one thread, go for string builder. It's faster. But if you're dealing with multiple threads, string buffer is your friend. Quiz time. What will be the output of this code snippet? Drop your answer in the comments. And don't forget to follow for more Java tips.
Hey Java learners! Today, we're going to learn about methods. Imagine methods as little helpers that do specific tasks in your code. Just like how you might have a morning routine with specific steps, methods let you break down your code into smaller, manageable pieces. Let's look at an example. In this example is a method that takes two numbers, adds them together, and returns the result. You can call this method whenever you need to add two numbers. No need to rewrite the code each time. Methods help keep your code organized, make it reusable, and easier to read. Think of them as your personal assistants in coding, delegating tasks so you don't have to do all the work yourself. Quick tip: always give your methods clear, descriptive names so it's easy to know what they do. Quiz time. Suppose you have a method calculate int a int b that returns a plus b asterisk b. If you call calculate 3, 4, what would be the result? Drop your answers in the comments below. Hey Java learners! Today we're diving into method overloading, a powerful feature that lets you use the same method name with different parameters. Imagine you're ordering a pizza. You can order it with different toppings, sizes, and crusts, but it's still called a pizza. That's what method overloading is like in Java. One name, multiple ways to use it. Here we have 3 add methods, but they differ in the number or type of parameters. This allows us to perform different tasks with the same method name, making our code cleaner and more intuitive. Method overloading is super handy when you want similar operations with slight variations, just like how you customize your pizza. Quiz time. If you call add 5 3.0, which method will Java choose? Let us know in the comments, and don't forget to follow for more Java tips.
If you don't like complicated code but still want powerful solutions, then Recursion is your new best friend. Recursion might sound fancy, but it's super cool. Imagine Russian nesting dolls. Each doll opens to reveal a smaller one, until you reach the tiniest doll that doesn't open. That's your base case. So what's recursion? It's when a method calls itself to solve smaller chunks of a problem. For example, calculating factorials. The factorial of 5, written as 5, is 531. In Java, you can write it like this. If n is 5, the method calls itself with n, 1, which is 4. This keeps happening until n becomes 0, where it stops and returns 1. Then the results multiply back up the chain. Recursion is awesome for tasks like traversing directories or solving puzzles like the Tower of Hanoi. Quick quiz. If you call greet 3 in this program, what will be the output? Drop your answers in the comments.
Hey there, learners! Today, we're diving into the core of Java classes and objects. Imagine you're playing a game where you design your own character. You define traits like strength, speed, and health, right? In Java, we do something similar with classes. A class is like a blueprint. It defines the properties or attributes and behaviors or methods that your objects will have. For example, if we're creating a car class, it might have attributes like color, make, and speed, and behaviors like drive and brake. An object is like the actual car you drive around in the game. It's an instance of the class, with specific values for those attributes. So, if you create a car object, you might have a red Toyota that can drive at 120 miles per hour. Here's a quick example in code. And to create an object, this will print. The car is driving at 120 miles per hour. You've just created a car object from your blueprint. Now here's a quiz for you. If you create another object from the car class with a different color and speed, will the first car's attributes change too? Drop your answers in the comments. And don't forget to like, share, and follow for more Java insights. Ready to crack the code on Java constructors? Let's get started. So, what exactly is a constructor? Think of it as a special method that runs when you create an object in Java. But here's the catch. It's not really a method. Constructors share the same name as the class and don't have a return type, not even void. Their job? To set up your object with initial values or run any startup code needed. Imagine a class called car. When you create a car object, the constructor can set the color, model, or even make the engine roar. Here's a quick example. This is a car class with a color property. Notice how the constructor shares the same name as the class, car. When we create a new car and pass red as an argument, the constructor sets the car's color to red. Now, here's the fun part. Quiz time. If you first create a car object with the color red using new car red, and then you create another car object with the color blue using new car blue, which color will your car have? Red, blue, or both? Drop your answer in the comments. Follow for more Java tips. Hey Java learners! Today, we're diving into the this keyword, a small but mighty tool in your coding toolkit. So, what exactly is this? Imagine you have two friends named Alex. To avoid confusion, you might say, this Alex, pointing to the one next to you. In Java, the this keyword works similarly. It helps Java know which variable or method you're talking about, especially when things have the same name. Here's an example. In this constructor, both the parameter and the class variable are named color. Using this.color equals color, we're telling Java, hey, set the class variable color to the value passed in the parameter. Without this, Java wouldn't know which color we're referring to. Remember, when you create a new object like car equals new car red, the this keyword ensures that each object handles its own data independently. Quiz time. In the following code, when you print mycar.color, what will be the output and why? Comment your answers below, and don't forget to follow for more Java tips. Hey learners, today we're diving into the world of in Java. Imagine you have a blueprint for a car. Now if you want to create a sports car, instead of starting from scratch, you can just inherit the car blueprint and add some sporty features. That's what inheritance is in Java. It allows one class to inherit fields and methods from another. Here's a simple example. We have a vehicle class with a method to display the type of vehicle. Then, we create a car class that inherits from vehicle. Now, car automatically has access to the vehicle methods, plus we can add more specific ones like showing the car model. Why is this useful? It keeps our code clean, organized, and prevents duplication, just like reusing the car blueprint instead of redrawing it every time. So next time you want to create a new class, think about what you can inherit and save yourself some work. Quiz time. If the vehicle class has a method drive, and the car class overrides it, which version of drive gets called when we create a car object and use it? Drop your answers in the comments.
Hey learners, today we're diving into an essential concept in Java called method overriding. If you've been following along, you're already familiar with methods and inheritance. But what happens when a subclass needs to do something a bit differently from its parent class? That's where method overriding comes in. Imagine you're working in a company, and your boss gives you a task. You know the task, but you have a more efficient way to do it. Method overriding is like you taking that task and doing it your way instead of following your boss's exact steps. Let's see this in action with a simple example. We'll start by creating a parent class called animal that has a method named sound. Then, we'll create a subclass called dog that overrides the sound method to provide its own specific implementation. When we call the sound method on a dog object, Java uses the method from the dog class, not the animal class. When we call the sound method on a dog object, Java uses the method from the dog class, not the animal class. Method overriding lets us define behavior that's specific to a subclass, giving us more flexibility in our code. Quiz time. What will the draw method print for each object? Why does the output differ for the myCircle object? If you found this helpful, make sure to like and share, and follow for more Java tips. See you in the next video. Why do 90% of Java learners love the super keyword? Let's find out. Imagine you've got a family recipe and you want to tweak it just a bit. The super keyword in Java is like that. It lets you call methods or access variables from the parent class while making your own customizations in the child class. Here's a simple example. Suppose we have a parent class called vehicle with a method displayInfo. Then, we create a subclass called car that overrides the displayInfo method. By using super.displayInfo in the car class, we can first call the method from the parent class, before adding details unique to car. The super keyword also lets you invoke the parent class's constructor, ensuring everything's set up correctly before diving into the subclass's specifics. Quick quiz. If super can access a parent method in a subclass, can it also access a private variable from the parent class? Drop your answer in the comments. If you found this useful, like, share, and follow for more Java tips. See you in the next video. This is why you need to know Java polymorphism. It's your secret coding power. Today, we're diving into polymorphism in Java, specifically runtime polymorphism or method overriding. Imagine having a superhero with different disguises for different missions. In Java, this means a subclass can override a method from its parent class to provide its own specific behavior. Let's break it down. Start with a parent class, animal, with a sound method. Then create child classes, dog and cat, each overriding the sound method with their own sounds. Here's the magic. We create an array of animal objects holding dog and cat instances. When we loop through the array and call the sound method, Java knows exactly which sound to make based on the object type. This is runtime polymorphism. One interface, many behaviors. For compile time polymorphism, check out the video tagged here. Quiz time. If we have an animal array with dog, cat, and bird objects, and we loop through this array calling the sound method, what will the output be? Comment below. If this helped, hit like and share. Follow for more Java tips. See you next time. I'm sure you've heard the news. Abstract classes in Java aren't as tricky as you might think. Abstract classes are like blueprints. You can't create objects from them directly, but they serve as templates for other classes. Here's an example. We have an abstract class called animal with an abstract method sound. Notice there's no body for the sound method. It's just a placeholder. Now, when we create a dog class that extends animal, we must define the sound method. This allows us to enforce certain behaviors while giving each subclass its own way of doing things. Quick quiz. What happens if you try to instantiate an abstract class? Drop your answer in the comments. If this helped, hit like and share for more Java tips. See you next time.
Hey learners! Today, we're exploring another core concept in Java interfaces. Ever wondered how to enforce a contract for classes without worrying about inheritance? That's where interfaces come in. Think of an interface like a contract. It's a blueprint that defines what methods a class should have, but it doesn't specify how those methods should work. In Java, you use the interface keyword to define one. For example, let's create an interface called animal actions, with methods like eat and sleep. These methods don't have bodies, they're just signatures. Now, when a class like dog or cat implements the animal actions interface, it must provide concrete implementations for all of those methods. This allows different classes to follow the same set of rules while still having their own unique behavior. Quick quiz. What happens if a class implements an interface but doesn't define all its methods? Drop your answer in the comments. If this helped, hit like and share for more Java tips. And don't forget to follow for the latest updates. See you in the next video.
Hey learners! Today we're talking about packages in Java. Think of packages as folders on your computer. Just like you organize your files into different folders, you can organize your Java classes into different packages. This helps keep your code clean, organized, and easy to manage, especially as your projects grow. For example, let's say you're building a game. You might have a package for player-related classes, another for game logic, and one more for utilities. By placing related classes together, you make your code easier to navigate and maintain. Creating a package is simple. You just declare it at the top of your Java file using the package keyword followed by the package name like this, packagegame.logic. Now all the classes in this file belong to the game.logic package. Packages also help prevent naming conflicts. You can have classes with the same name in different packages without any issues. It's like having a photos folder for vacation pics and another photos folder for work images. They don't get mixed up. Quick quiz. Imagine you have two classes with the same name in different packages. How would you import both classes in the same Java file and use them without conflict? Drop your answer in the comments. If this helped, hit like and share for more Java tips. Follow for more updates and see you in the next video.
Hey learners, today we're diving into exception handling in Java. Imagine you're playing a video game and suddenly a glitch occurs. Instead of crashing, the game catches the error and takes you back to a safe point. That's what exception handling does for your Java programs. It helps your code handle unexpected errors gracefully. In Java, you can use a try-catch block to handle exceptions. The code that might throw an error goes inside the try block, and if an error occurs, the catch block runs. For example, trying to divide a number by 0 can cause an exception, but with a try-catch block, you can catch that error and display a friendly message instead. And don't forget the finally block. It's like the game saving your progress no matter what. Whether an exception occurs or not, the code inside the finally block will always execute. Lastly, you can use the throw keyword to create your own exceptions, like signaling a game over when a player's health reaches 0. Quick quiz. What happens if you don't handle an exception in your code? Drop your answer in the comments. If this helped, hit like and share, and don't forget to follow for more Java tips. See you in the next video.
Want to make your Java code smarter and cleaner? Custom exceptions are your new best friend. Sometimes those standard Java exceptions just don't cut it. Imagine you're building a banking app. What happens if someone tries to withdraw more money than they have? Enter custom exceptions. Creating one is a breeze. Just define a new class that extends the exception class. Need to handle insufficient funds? Make an insufficient funds exception class. In your code, use the throw keyword to toss this exception when needed, and catch it with a try-catch block to handle it gracefully. Voila! Your code is now more readable and easier to debug. Quick quiz. If you create a custom exception and don't catch it, what will happen? Drop your answer in the comments. If this helped, hit like and share for more Java tips. Follow for updates, and see you in the next video.
If your code looks like a tangled mess, you're a Java learner in need of collections. Imagine you're building a game and need to store a list of players, track their scores, or manage a deck of cards. Instead of using arrays with fixed sizes, Java's collections framework offers flexible, powerful tools like ArrayList, HashSet, and Hashmap. With collections, you can easily add, remove, search, and sort elements. For example, use an array list to store player names. Want to add a new player? No problem, just call add. The collections framework provides ready-to-use implementations that handle the heavy lifting for you. Whether you need a list, set, or map, there's a collection type that fits your needs. Quick quiz. What's the difference between a list and a set in Java? Drop your answer in the comments. If this helped, hit like and share. And don't forget to follow for more Java tips. See you in the next video.
Hey learners! Today we're diving into one of the most essential parts of Java's collections framework, the list interface. If you've ever needed to store an ordered collection of elements, then lists are your go-to. But here's the twist. There are two popular implementations, ArrayList and Linked List. Let's break it down. ArrayList is like a dynamic array. It's lightning fast when you need to access elements by index, but a bit slow because the rest of the elements need to shift around. Linked List, on the other hand, is more like a chain where each element points to the next one. This makes inserting or removing elements a breeze, but accessing an element by index takes longer since you have to traverse the list one by one. Which one should you use? If you're doing a lot of random access, go with ArrayList. If you're frequently adding or removing elements, Linked List might be your best bet. Quick quiz. If you need quick access to elements and often insert or remove them, which would you pick? ArrayList or Linked List? Share your thoughts in the comments. If this helped, hit like and share, and don't forget to follow for more Java tips. See you in the next video. Why do 70% of Java beginners get confused between HashSet and TreeSet? Let's clear it up. First up, HashSet. Think of it as a magic bag where every item is unique, no duplicates allowed. It doesn't maintain any order, but it's super fast for adding, removing, and checking elements. Perfect when you just need uniqueness without worrying about the order. Next, we have Treet. Imagine a sorted bookshelf where every book is in order. Treet stores elements in a natural sorted order, like alphabetical for strings, and ensures all elements are unique. While it might be a bit slower than HashSet due to the sorting, it's ideal when you need your elements sorted. So, which one should you use? Use HashSet for fast performance when order doesn't matter. Choose Treet when you need your elements to be sorted automatically. Quick quiz. If you need your set to be sorted automatically, which one would you choose? HashSet or Treet? Drop your answer in the comments. If this helped, hit like, share, and don't forget to follow for more Java tips. See you in the next video.
If your code looks like a jumbled mess, you need a Hashmap. Let's kick things off with Hashmap. Picture it like a super efficient address book. It stores data in key-value pairs, perfect for quick lookups and insertions. But here's the catch, it doesn't keep order. So entries can be all over the place. Now, switch gears to TreeMap. Imagine a sorted address book where everything's neatly arranged. TreeMap also stores data in key-value pairs, but keeps them sorted by keys. This means when you iterate over entries, they come out in ascending order. But it's a tad slower due to the sorting process. So, which one to pick? Go for Hashmap when speed is key and order doesn't matter. Choose TreeMap when you need your data sorted. Quick quiz. Need sorted order based on keys? Hashmap or TreeMap? Drop your answer in the comments. If this helped, hit like, share. And don't forget to follow for more Java tips. See you in the next video.
Am I the only one that didn't know iterators make life easier for Java loops? Let's dive in. Today, we're exploring iterators and the enhanced for loop to help you manage looping and modifying lists seamlessly. When you're iterating over a collection and need to remove or add elements, a regular for loop can lead to errors. But iterators? They provide a safe way with the remove method, avoiding those pesky concurrent modification exceptions. Here's how it works. With an iterator, you can safely remove Bob from the list while iterating. But if you're only reading data, the enhanced for loop is your best friend. Quick quiz. If you need to remove elements while iterating, which is safer, using an iterator or a regular for loop? Drop your answer in the comments. If this helped, hit like, share, and don't forget to follow for more Java tips. See you in the next video.
Ever wished you could write one piece of code that works for all data types? That's where Java generics come in. Let's dive in and find out. Imagine you're creating a box to store different things, numbers, text, or even objects. Without generics, you'd need a separate box for each type. But with generics, you can create one box that works for all types. Generics allow you to write code that can work with any data type while ensuring type safety. You can write it once and use it for integers, strings, or even custom objects. Pretty efficient, right? For example, if you're working with a list of numbers or strings, generics ensure that only valid data types are used, preventing errors at compile time instead of at runtime. So, whether you're storing player scores or game levels, generics have got you covered. Quick quiz. Imagine you have two methods, one that takes a list of integer and another that takes a list of string. If you want to create a single method that can work with any type of list, how can generics help you achieve this? Drop your answer in the comments. If this helped, hit like, share, and don't forget to follow for more Java tips. See you in the next video.
I bet you didn't know Lambda Expressions could simplify your Java code this much. Ready to see how? Ready to see how? Lambda Expressions let you implement functional interfaces in a more readable way, cutting down on boilerplate code. Imagine you need to print a list of names. Normally you'd write something like this, followed by the for each method with a consumer implementation. But with Lambda Expressions, you can simplify it too. See how much cleaner that is? Lambda Expressions make your code more readable and efficient, especially with collections or functional interfaces. Quick quiz. You have a list of numbers and need to print only the even ones. How would you use Lambda Expressions to do this in a single line of code? Drop your answers in the comments. If this helped, hit like, share, and don't forget to follow for more Java tips. See you in the next video.
Ever heard of functional interfaces in Java but not quite sure how they work? Let me break it down for you in the simplest way possible. Functional interfaces are one of Java's coolest features, especially if you're using Lambda Expressions. Think of them as blueprints with just one single method. They're perfect for making your code more readable and flexible. Here are some of the most common functional interfaces in Java Runnable. This one's your go-to when you need to run a block of code on a separate thread. Predicate, used when you need to return a Boolean result, like checking conditions. Function, converts input into output. Think of it like a one-step transformation. Consumer performs an action, but doesn't return anything. Let's take an example. Imagine you want to filter a list of numbers and print only the even ones. Using a predicate and consumer, this can be done with just a few lines of code. Here we use the predicate interface to filter out the even numbers from a list, and the consumer interface in the for each method to print them. It's that simple. Quick quiz. What would you use if you need to transform a list of strings into uppercase? A predicate, function, or consumer? Drop your answers in the comments. If this video helped, don't forget to hit like, share, and follow for more quick Java tips. This is why you need Java streams. Say goodbye to messy loops, and hello to clean, efficient code. Streams in Java let you handle data like a pro. Think of them as a pipeline where you can filter, map, and collect data without writing loops over and over again. Here's a quick example. Say you have a list of numbers, and you want to get only the even ones and print them. Without streams, you'd write a loop, but with streams, it's just one line. See how clean and readable that is? No manual loops, just data flowing through the pipeline, making your code more concise and easier to manage. Quick quiz. If you need to find the sum of all even numbers from a list, how would you do it using streams? Drop your answer in the comments below. If this helped, hit like, share, and follow for more Java tips. See you in the next video. Are you puzzled by Java file handling? Let's make file handling a breeze. Java provides built-in classes to handle files, whether you're reading, writing, or checking file properties. First, to create a file, you can use the file class. Need to write to the file? That's where FileWriter comes in. And to read the file, you can easily use Scanner. Using file handling in Java, you can easily manage data, logs, or even configuration files without much effort. Quick quiz. Imagine you need to check if a file already exists before writing to it. Which method would you use? Drop your answer in the comments. If this video helped, don't forget to hit like, share, and subscribe for more Java tips and tricks. See you in the next video. Did you know you can save an entire object to a file in Java? Yep, that's called serialization. Let me show you how it works. Serialization allows you to convert an object into a stream of bytes. Why? So, you can save it to a file, send it over a network, or even store it in a database. For example, you have an object of a class, say player. If you serialize it, you can save that object state and reload it later with deserialization. Here's a quick breakdown. Serialization converts your object into a byte stream. Deserialization converts that byte stream back into an object. Use the object output stream class for serialization and object input stream for deserialization in Java. It's that easy to save and load your objects. Quick quiz. If you want to skip serializing some fields in an object, which keyword would you use? Drop your answer in the comments. If this video helped, don't forget to hit like, share, and subscribe for more Java tips. See you in the next video. Struggling with dates and times in Java? Let me show you how easy it is with the modern date and time API. To get today's date, use local date. Need the time? Use local time. Want both? Local date time has you covered. And handling time zones? No problem with zone date time. Quick quiz. How would you add 5 days to the current date in Java? Drop your answer in the comments. If this video helped, hit like, share, and follow for more Java tips. See you in the next one. You need to hear this if you're a Java developer looking to boost performance. Mastering multithreading will change the game. In Java, multithreading allows your program to run multiple threads in parallel, meaning tasks can be performed simultaneously. Imagine you're playing a video game. While the game logic is running, the sound effects are playing in the background and inputs are being registered, all at the same time. That's multithreading in action. Java provides 2 ways to create threads: extending the thread class or implementing the runnable interface. Multithreading is great for improving performance, especially with tasks like file handling, data processing, or network operations. Quick quiz. Why do we need the synchronized keyword in multithreading? Drop your answer in the comments. If this video helped, don't forget to hit like, share, and subscribe for more Java tips. See you in the next video. This is gonna blow your mind. Synchronization in Java multithreading is like traffic lights for data access. Let's dive in. When multiple threads try to access shared resources simultaneously, chaos can ensue. This chaos is called a race condition, where the outcome hinges on which thread gets there first. Sounds risky, right? So how do we prevent this? Enter synchronization. Think of it as a bouncer at a club, letting in one thread at a time to access the shared resource. For example, if we have a method that updates a counter, making it synchronized ensures only one thread can perform this action at a time. This keeps our data safe and our program predictable. Quick quiz. Why is synchronized important in multithreading? Drop your answer in the comments. If this video helped, don't forget to hit like, share, and subscribe for more Java tips. See you in the next video. Ever feel like managing threads in Java is tricky? Java's concurrency utilities are here to make life easier. Let me show you how. Imagine you have a task that takes a long time to complete, like downloading large files or processing data. Instead of handling threads manually, you can use Executor Service, part of Java's concurrency API. It helps manage and control thread execution for you. Want to run tasks periodically? Use Scheduled Executor Service to automate that process with precision. And if you need to control access to shared resources, locks and semaphores will keep your threads in check. Here's a quick example. Want to execute a batch of tasks all at once? Use executors.newFixedThreadPool to create a pool of threads and watch them handle the load efficiently. Quick quiz. When would you use Scheduled Executor Service in your code? Drop your answer in the comments. If this video helped, hit like, share, and subscribe for more Java tips. See you in the next one.
I'm sure you've heard the news. Java makes networking super simple. But how? Let's find out. Java's magic wand for networking? The socket class. Think of it as a virtual phone line between devices. At the heart of it, you have two main players, server socket and socket. The server socket is like a friendly doorman, always ready to welcome new connections. Meanwhile, the socket is the eager visitor, ready to knock on the door and start chatting. Here's how it works. 1. Use server socket to create a server. 1. Use socket on the client side to establish a connection. Easy, right? Quick quiz. How do you send data between a client and a server in Java? Drop your answer in the comments. If this video helped, don't forget to like, share, and subscribe for more Java tips. See you in the next video.
Are you a programming student? Want to master modern Java GUIs? JavaFX is your answer. JavaFX is the go-to framework for building modern, rich user interfaces in Java. Want buttons, sliders, or charts in your app? JavaFX has got you covered. Here's the basic rundown. Stage. Think of this as the window of your app. Scene. It holds all the UI components, like buttons and text fields. Nodes. These are your actual UI components, which you can arrange in the scene. You can use FXML to design your UI separately from the code, or create everything programmatically. Quick quiz. What's the difference between a stage and a scene in JavaFX? Drop your answer in the comments. If this video helped, don't forget to hit like, share, and subscribe for more Java tips. See you in the next one.
What's cooler than a secret code? Java annotations, of course. Let's dive in. Annotations in Java are like tiny post-it notes for your code. They provide metadata, giving instructions to the compiler, or even helping out at runtime. You've probably seen @override and @deprecated. But did you know you can create your own custom annotations? Yep, total game changer. So why should you care? Annotations make your code cleaner and more manageable. Imagine using frameworks like Spring or Hibernate. Annotations help with configuration and cut down on boilerplate code. Less code, fewer bugs, more time to binge watch your favorite show. Win-win. Quick quiz. What's the use of @override in Java? Drop your answer in the comments, smarty pants. If this video helped unlock the power of Java annotations for you, smash that like button, share with your coding buddies, and hit subscribe for more awesome Java tips. Catch you in the next one.
Don't get Java, but still want to code? Let's do a speed run of Java basics. All right, Java learners, let's do a super quick recap of Java basics. We've covered variables like int and string, data types from primitive to complex, loops, while, for, do while, methods, your mini programs within programs, concepts like inheritance, where classes get traits from other classes, and even multithreading, running multiple tasks at once. But don't worry if you missed anything, we've got a whole playlist called 50 Days of Java, where we dive deep into each of these topics with detailed explanations and sample code. You'll find everything from beginner tips to advanced concepts. So if you want to master Java, head over to the playlist now and level up your skills. Quick quiz, what's your favorite Java feature so far? Drop your answer in the comments. Think you've mastered Java? Think again. We're talking advanced Java today. Streams for efficient data processing, lambdas for cleaner code, and generics for flexibility. Ever wondered how to turbocharge your programs? Say hello to concurrency and multi-threading? But wait, there's more. Frameworks like Spring and Hibernate can take your projects to the next level. And don't forget, advanced design patterns are your secret weapon. Hungry for more? Check out our 50 Days of Java playlist for deep dives into all these topics and more. Quick quiz. What's your favorite advanced Java topic so far? Drop your answers in the comments. If this video helped, smash that like button, share, and subscribe. See you in the next one.
If your code looks like spaghetti, it's time to whip up some Java magic. Ready to cook up some projects? Java is everywhere, from desktop apps to web services. Imagine building your own library management system or an e-commerce platform. How about creating your own social media tool? And guess what? Java powers Android apps too, so mobile development is just a click away. With frameworks like Spring Boot, you can whip up powerful backends for websites and APIs. It's like having a superpower in your coding toolkit. So, what's your next big project? Quick quiz. What's your dream Java project? Drop it in the comments below. If this video inspired you, don't forget to like, share, and subscribe for more project ideas. Catch you in the next one. Why aren't more people talking about leveling up in Java? This is gonna blow your mind. You've made it through tons of Java basics and advanced topics, variables, loops, OOP, multithreading, and even frameworks like Spring and Hibernate. But what's next? Let's recap what we've covered. From mastering the basics to diving deep into concurrency, there's always more to learn. So, where do you go from here? Check out our 50 Days of Java playlist for in-depth videos on each topic, complete with sample codes and real-world examples. Want more? Stay tuned for upcoming videos exploring even more advanced topics and projects. Quick quiz. What's one Java concept you're ready to explore next? Drop your answer in the comments. Like, share, and subscribe, and let's keep leveling up your Java skills together. See you in the next one.